Welcome to everybody joining us on our first webinar of 2025. We're so excited to be back with you, bringing you such fresh, awesome content. Our first webinar is Vlad and I together talking about Wi-Fi design. And Vlad, I know you've got some super cool new features
of course,
to show everybody. So I can't wait to dive in. But before we do that, Stu, why don't you do a quick round of introductions?
Absolutely. So today we've got a really special day here actually at Ekahau, and we've got none other than Vladimir. Well, we call him Vlad, but
Yeah.
Vlad here joining. He's actually part of the product director of our product line from an Ekahau perspective when you're talking about AI Pro online. So this is really actually great that Matt's there in Helsinki today, syncing up with from Vlad, and of course we've got none other than Mr. Matt Starling, right? So he's actually our senior product director. For those you don't know, I don't think he needs much introduction, but I'm going to give it to him anyways because. And then we've got, of course, Dale Tyler. He was on the U.S. side here. Saw the introductions, but Dale actually is on the systems engineering side of on the sales engineering side of Americas, and he's going to join us in the back end for on the chat side. So get your chat your questions ready, and of course myself, me or Sidekick Stu or Wireless Stu, I'm the global director of community and customer engagement, and we'll see you guys a little bit later. Over to you, Matt.
Thank you very much, Psychic Stu. And before we actually start the webinar today, we wanted just to remind everybody, because I know we've got so many new people here, that if you want to stay in touch after the webinar, we have been having such fantastic conversations in our Ekahau public Slack channel, free, and anybody welcome to join. More recently, we've had some awesome chats around people asking around configuration settings for the radios of their access points, and if they should use some profiles, if they should set it statically, if they should use some ranges. So if you want to stay in touch after the webinar, I know you love talking in the chat of the webinar we have. You can now sign up to the Slack, and we look forward to seeing you there. So what we're going to be covering on today's webinar is all about Wi-Fi design. How do you get prepared for the upcoming Wi-Fi design? Are there kind of some different approaches that you might be able to take using Ekahau tools? And we have got so many great live, awesome demos for you as well. And then at the end of the webinar, we're going to summarize and wrap up with some best practices. So let's jump in. So I can't say anyone that asks me or mentions Wi-Fi design, the first thing that comes to my mind is coverage. Seeing access points on a floor plans with their heat maps being generated, primary coverage, secondary coverage is the first thing that comes to my mind. But the other thing that we've got to think about is what actually affects our Wi-Fi coverage or the signals coming from the radios of the access point. So why don't we take a look at an example we've got here. So we've got an access point with its radios broadcasting on the 3 frequency bands, 2.4, 5, and 6 gigahertz. And we're looking at the natural degradation of the signal as it comes out of the transmit radio from the access point. And you can see in the distance related to here, in the first few meters, there's quite a big drop in the degradation of the signal. But this is at this point here, we're just seeing what happens in free space. But then there's something that happens here. When you have a piece of material, let's say a drywall, for example, or a brick wall, or concrete, or even glass, that causes something to our RF waves that's called attenuation. And different types of materials that you will have in your environment, they will cause different levels of attenuation, effectively absorbing some of that signal. So as it passes through the material, some of that energy is going to get lost, and you're going to lose some of the power coming from the radio from the access point. Now, also something to factor in when thinking about your environment and your different types of materials that you've got on site, they can actually cause different things to happen to our radio waves. So for example, if you've got lots of glass or lots of reflective materials on site, that can actually cause the RF waves as they're traveling through the air to hit a piece of material and actually bounce back. That's called reflections. Other pieces of material can actually cause something called diffractions. So as an RF wave hits a piece of material, it can actually bend around it. And the reason why I mention that is because when you visualize heat maps in Ekahau, we automatically calculate for you what happens with that natural degradation of the signal from your radio. That's called free space path loss. We also subtract the attenuation values of your materials, but also we calculate reflections and diffractions. So we give you the most accurate heat maps that you can possibly have from using our tools. So these are just some common factors and attenuation materials of some of the typical materials you will have in your environment, but always worth going on site, measuring and checking to make sure what you actually have there. When it comes to a Wi-Fi design, the most critical part of it is actually gathering the requirements. So you could have two identical warehouses, but the business objectives for each of the warehouses could be so different that you would actually end up designing and installing the access points in different ways, maybe at different heights, maybe in different locations, maybe using different antennas. So it's really key to actually understand what is the business requirements from the stakeholder, to define what they actually want the outcome of the Wi-Fi to be up front. And that's when you can then take that information, you maybe then have some technical conversations, you're going to factor in what type of access point you're going to be using, from which vendor, maybe you're going to be using some external antennas, and you're going to then define, what areas are in scope. I'm sure lots of us on the webinar today, you've probably had conversations with your stakeholders, your customers, and you ask them, where would you like your Wi-Fi? And they go, everywhere. And you go, okay, everywhere. So you mean bathrooms, you mean stairwells, you mean the garage, you mean the car park, you mean outdoors. That's going to be quite a few more access points. They go, whoa, hold on a second. Let's scale that back a little bit. Maybe we don't need them in some locations. Then the regulatory domain there is really important because depending on where you're designing or installing the Wi-Fi network, you can have access to different channels that you can use, different transmit power, maybe even different parts of the spectrum. So that's a really key thing that you want to make sure you ascertain up front. Then finally, what we like to do is define something called the RF requirement. So this is going to be the statistics and the criteria that you're going to look at inside of Ekahau. So in terms of coverage, are you going to be designing to minus 67 dBm? Is it going to be slightly more? Is it going to be slightly less? How much co-channel interference are you willing to accept for the network, and defining all of your data rates and things like that. Now, with Ekahau, we can actually give you two different paths to designing your Wi-Fi network. And on the left-hand side, you've got the existing network redesign. And what we can actually do here is, if you've got a network, you can actually just go with your Sidekick 2 to the site, perform a survey of the environment, and then sync that data to our cloud, to AI Pro Online. And then without having to draw kind of any walls or any obstacles, you can actually visually see changes to your network, like moving access points, changing access point models. Maybe you have an old network, like that's just 2.4 and 5 gigahertz only, and you want to simulate upgrading to a 6 gigahertz capable Wi-Fi 7 network. You can totally do that using Ekahau AI Pro Online. So what is it we use? Is it AI and machine learning?
Yes, AI environment is the key. Okay. And Sidekick 2, of course.
Okay, yes. So that saves you a ton of time, not having to draw any kind of walls or any kind of obstacles, things like that. And then let's talk about the other option here on the right-hand side that you can do with Ekahau AI Pro, the desktop app and the online version. So this is what we maybe refer to as like your traditional predictive modeling, where maybe you can't go on site yet. So you're going to just upload a floor plan, you're going to set a scale, define your building, you're going to draw obstacles, and then you're going to place the simulated access points on the map to see the predictive coverage. And then at some point you'd go on site with your Sidekick, measure what's really there, and then update all of your materials, and then your design accordingly, reflective based on what you found on site. So what I really wanted to do is I want to take you through some of the steps that I would go through, and maybe you would go through, for when you're going to do a network redesign. So step one is you'd go on site, with your Sidekick 2, the floor plan, you'd capture data of the environment. And here we're really looking to understand things like, what is the attenuation of your materials on site? I know personally before, I've been caught out with assuming that from looking at a wall, it's drywall, but actually behind the drywall, there was brick. So the only way you can really know that, unless you've got X-ray vision, which I don't, is you need to measure with your Sidekick and find out what is actually there, so you can have the most accurate model of your environment. The other great thing about doing a survey is you can find interferers. Maybe there's some non-Wi-Fi interference there that you're going to need to avoid some of the channels. Perhaps you've got lots of noisy neighbors and you want to avoid some of the channels that they're occupying. And the other key thing that's so good about going on site is that you can look up, you can see the mounting locations, you can see if you've got any cabling constraints, maybe there's some architectural challenges and aesthetic concerns with where you can place access points or not. So it's really key and great to be able to go on site. The next step, once you've captured that data, I would analyze it. And this is where I would say that you would be able to see, maybe there's some quick wins. So you're checking to see that, does the existing network meet some of the requirements for the customer or not? But there is an application that we have in the cloud called Optimizer, Vlad. I know you're very, very familiar with. that once you've done a survey of your space, you can push it to our optimizer and it will automatically analyze your network for you and give you a bunch of recommendations and some step-by-step guides for things that you can do to improve the performance of your network. So maybe there's some quick wins that you can do there to actually make the network better whilst you're going through the process of the redesign. Step 3, this is when I would be looking at the network and asking myself, hey, you know, to save the customer or the stakeholder some money, can I do a one-to-one rip and replace of where the existing AP locations are to save them from having to run new cables, from having to do new mounting locations? But the reality is sometimes that might work, sometimes it might not, because the way that the Wi-Fi was designed 3, 4, 5, 6, 7 years ago isn't going to be necessarily what they would be actually wanting the performance of the network to be today in 2025. So here you can see things like, do I need to adjust some locations? Do I need to add some more access points to meet these new requirements? But the great thing that Vlad is going to show you in just a few moments' time with Ekahau AI Pro Online is that you have an awesome way of being able to visualize this now. Before, you would have to do a survey, you would have to draw everything manually, make sure you've got everything set correctly to be able to see any of that. So it saves a huge amount of time. Then step 4 is the deployment and the configuration of your new design. And this is a really key part that I would recommend that you keep close with, because if the configuration doesn't match how you've designed the new Wi-Fi network, then when it gets installed, the performance may not be the expected rate from what you had designed, because maybe the transmit power is all out of control. Maybe the channels and the channel widths are not set how you were planning them to be. And the other thing that I've noticed, especially in the past projects that I've worked on, if you don't work with the installation team, sometimes your access points can get installed in positions that you didn't recommend. Sometimes they can get installed around material that's going to cause lots of interference for your access points. So a real key tip here is to make sure that you pay close attention to this to ensure it's configured and installed as you wished it to be. Then once your network is, your new network is in, step 5 is when you would do a post-deployment survey, a validation, making sure the network is deployed, configured, working as expected. You've got a great opportunity here to, again, run it through Optimizer, see if there's any improvements you can make and tweak anything there that you need to do. So Vlad, on that note, why don't we jump into a quick demo of that approach?
Yes, absolutely. And as you mentioned, we are living on the edge. We are doing live demos today. So we are wearing our capes. And what I would like to show you is actually the path 1 that Matt was talking about. So basically you have a survey file, you have imported the project into AI Pro Online. And here we have already generated AI environments. So you don't need to draw any walls or any obstacles. The Sidekick 2 measurements have been analyzed, and we basically know how the signal will propagate, even if you start moving the access points from your survey data around. You see the heat maps are changing, the signal is propagating differently. So we have all that data already in the project. So on that note, you see that actually in this project, we have only 2 bands, 2.4 and 5, right? So the APs here are quite outdated maybe. So what we want to do here is we want to simulate what it will be or what will happen when you actually try to replace those 2-band APs with a tri-band AP. So Wi-Fi 7, of course, right? What else can there be?
Who doesn't want to upgrade to Wi-Fi 7 now, right? We saw people in the chat earlier saying that one of their New Year's resolutions is to upgrade to Wi-Fi 7. Why don't we show them how they can do it with AI Pro Online?
Yeah, absolutely. So it's super easy.
But hey, Vlad, before you do that though, actually, the installed access points, are you able to actually relocate them and see the updated?
Yeah, absolutely, yes. So you can move them around, right? So you can even test different locations or different positions and any AP models. Like for example, in this rip and replace case, I keep the positions as they are. I just select the APs that I already have from the measure data, and only thing I need to do is select another AP model. So I still keep Aruba as the model, and I select 755 as my preferred Wi-Fi 7 AP. And I don't know, did you notice? We already have the design, right?
Wow, that was fast.
Yeah, that was pretty fast. I couldn't even say that. Wait for a second. I didn't have to say that. So we already have APs, Wi-Fi 7 APs ready here. An interesting thing.
Wait, hold on, Vlad. You can
Yeah.
now see the 6 gigahertz predicted coverage.
Absolutely. Let's just change to 6 gigahertz band.
Nice.
And from this design, we can see that we have 100% pass rate, meaning that the coverage is actually okay with this rip and replace scenario. So I don't need to worry about coverage with this. I don't need to install any new APs if I don't want to. But it's always good to check also the secondary coverage. Let's change to that heat map. It looks also that is perfect, and also maybe channel interference. You see that there are no
actually, Vlad,
problems.
someone just mentioned in the chat that when we changed the access points, it reset all of the transmit power of the radios to the default that we use in Ekahau. And then what's actually happening with the channels? Are we doing that manually, or is there some sort of like automation going on here?
No, actually, what's going on here is by default, we are automatically optimizing your channels. So the reason why you see a perfect channel interference heat map is that we have recalculated the channels, so we always do that. Of course, if you want to do some manual changes, we have an option. So you just select an AP, then you select the properties, and instead of auto channels, you can always opt to choose channels manually. So you just turn the automatic channel planning off, and then you can set any channels for your plan.
The other thing just to mention there is you can also change the transmit power, right?
Yes, so TX power you can change directly from here. So you can put any TX power and see what's the impact there. So super easy and fast.
Okay. Someone was saying that there's a bit of echo from having the 2 mics on, so I'll put it back down to just to 1. Let us know in the chat if it's any better. So and when you can hear you, Vlad.
And I try not to shout that loud. Maybe that's also my.
You guys are sounding pretty good.
Okay. Okay. Cool. So. And as I mentioned, also this new replaced APs, you can move around, see how they behave. And you can also try what happens if you need to add new APs, right? So let's take the same Aruba model, 755, and place more APs here. So for example, here's a spot. So you can see that this project with this AI environment is super easy to use. So you can add new APs, remove APs, move them around. And that's all due to the AI environment with Scikit-2 measurements. So very easy to use, and hope it will save a lot of time.
Yeah. Okay, now people are saying low volume, so I'm going to turn it back on. All right. So okay. Now we're back to where it was before. So hopefully there's not too much echo and you can hear us okay. All right. Let me jump back to sharing some slides. Can you? I'm going to replace the current share. And then jump back into the deck. So thank you so much for that, Vlad, for that awesome demo. Now let's talk about the new network design approach and the steps that you would take to go and do a brand new design for a environment that maybe doesn't have any Wi-Fi there. So in the traditional predictive modeling, the first step, I would call this my predictive design draft. And this is where I'm going to be importing the floor plan. I'm going to be setting the scale. I'm going to be drawing obstacles and configuring the attenuation of these objects. But the thing here is that I'm making assumptions. So I haven't been to site yet, so I don't know if it's a 3 dB drywall compared to a 6 dB insulated wall, or if there's some brick in there and the different materials on site. So I'm just making assumptions and I place them at access points on the map. But again, this is estimated because I don't know the exact mounting locations yet. I don't know if there's any restrictions, but maybe I need to get a rough bill of materials so I can then build out the rest of the network, or maybe the site is being constructed and I can't get on site yet. So that's what would be step 1 for me. Then when the site is a bit more constructed, or I can get to site to do the site survey, this is when I would again do that pre-deployment survey, the same thing that we covered with the previous slide there, making sure I capture data, understand the attenuation, discover any interferers, and then I'm looking at mounting locations. But this only really works if there's an existing like Wi-Fi network there. And this I'm gonna call this like step 2.5. So again, like still in the pre-deployment phase, if there's no existing Wi-Fi network there, you're going to maybe need to do something that's called an AP on a stick survey. So that's what this abbreviation is here. And this is where you would take the intended access point model and or antenna that you're using in your design or you're planning to deploy. You stick it in the locations and then you measure to actually get the real measurements from that access point in the positions, and then you can understand how it's going to behave in the environment, and then you can then use that data to go back and update your model. So my step 3 here is this is when I then use all of that information that I've gathered from being on site to go and update the information in my predictive model to make it as accurate as possible. So this is where I update the attenuation of the materials. I look at if I need to adjust any of my suggested AP locations, or maybe I need to add in a couple extra, or maybe I even might need to remove some, who knows? So the only way you know for sure is by going on site. Then step 4, just like we spoke about earlier, the configuration. It's such a key, crucial part of the network design phase, is keeping close to it. Really watch out for the managing of that physical installation of the new access points. It's caught me out in the past before, and I've been to site to assess many networks that didn't install the APs properly, and it just wreaks havoc on the performance. And then finally, step 5, that post-deployment survey is always key. Make sure you go and do it, run it through Optimizer, see if there's anything you can do there to improve the network. Now, Vlad, this is very exciting because I know you've got lots and lots of amazing stuff to show everybody. I know they haven't seen this yet, so for the first time, there's going to be lots of really cool things you're going to be seeing with our new AI Pro online features.
Yes, absolutely. And I would like to highlight some of the new things that are not yet public. So I will point your attention maybe to those things. So, but are coming very soon. As you see, we're doing live demos here. So let's start with the path 2 Matt was mentioning. So basically creating your project based on some floor map. So let's create a new project. I will call it demo project, very inventive name. So what you can see here that will be coming to AI Pro Online, many of our users have been asking, okay, if I have a classic AI Pro design project with walls, whatever defined, how can I bring it to AI Pro Online? As of today, you cannot, but very soon you will be able to. So you here see the third option, continue a design. So that path will take you to actually importing your design project from AI Pro to AI Pro Online. That's not the path we are taking now in this demo, but now you know that it's coming very soon. Okay, let's create a new project and see, select some simple floor map. I use an office floor map from our office here in Helsinki, and
But Vlad, I just noticed, was that a PNG file that you brought in though?
Yes, it's a PNG file. We can use JPEG or whatever. So AI Pro Online supports all the formats, including PDF or CAD files. You can bring them in. But most importantly, I think, is that our automation tools can work on all the formats. So that's the key here.
I just want to ask a quick question to the audience that work on Wi-Fi projects. When you're speaking with the stakeholders and they provide you floor plans, what is the most common floor plan type that you get provided with? Do you get CAD files? Do you get PDF files with the layers defined? Do you usually just get a flat PDF? Do you get JPEG? Do you get PNG? Or sometimes you just get nothing and maybe you need to do a Just Go survey crayons. Yeah, I love that. Yeah, back of a napkin. Do you get Excel sheets? Yeah, that's happened to me before. Yeah, nothing.
We can work with that as well. PDF seems to be dominating on a quick scheme.
MS Paint. I just saw that's a
MS Paint.
You guys are blowing up the chat there. That is just amazing.
Chicken scratches, yeah. I mean, I saw a lot of people there saying a lot of people don't get floor plans. So if you haven't seen our Just Go survey mode, we'll cover it maybe in the next webinar or something like that. But it's awesome if you're ever in that situation where you haven't been provided a floor plan. At least you can still do a survey and get a floor plan out of it. But it seems to me that people get quite a lot of like flat PDFs or just some like JPEG and PNG files. Okay, interesting, cool.
DVG files as well, yeah. Interesting. Yeah. But in this case, we are using just PNG file, and you can crop it, rotate it. Here I have some colors. I can turn them off. I can play with opacity, so I can maybe see some features more.
Sorry, that was very fast. You just had a bunch of colors on the floor plan, and you just got rid of it with one click.
Yes, because I don't see any colors. I'm colorblind, for example. I don't. Yeah. For whatever reason, you can remove them.
Yeah, so then it makes it easier to see the heat maps because it's all just, black, gray, or white.
Yeah, absolutely. And for usability, of course, when you draw walls, they're different colors, so they don't distract you so much.
Oh, that's a great new feature.
Yeah. So let's move forward. Then, of course, I guess familiar feature is setting the scale. So I have a scale marker here. As Matt always reminds you, if you have ability to use proper scale, don't use doors and other features in your floor plan to do that. Please use a proper scale here. But here I have 10 meters and I'm pretty much done with importing my floor image. I will be using a single floor image, although AI Pro Online obviously supports multi-floor and multi-building structures. But for this example, let's use just a single floor. Okay, so what's going on here? So basically, I need to define my environment, right? I don't have a survey to draw AI environment, so I need to define it myself. That happens by drawing walls and obstacles. And what you see if you select our wall tool is that we automatically already triggered AI environment detection. So we're analyzing this image and we will be proposing the obstacles. And I was babbling a bit, and it's done. So I was buying time to show this. Okay, so let's see what this will do. Let's place walls automatically. And in just one click, I have my walls. So let's maybe analyze what we have detected here. Matt has raised his hands in awe before the AI Pro Online magic, right? So.
But this is just insane. This is, guys, girls, this is just a PNG file, and look at the wall drawing that has happened on this. Like, this is insane. I would expect this from a CAD file, but that took barely 15 seconds in AI Pro Online. And what, Vlad, we've got.
I can show you. So we have not only just some walls, we have actually determined some types of materials. So we determined this as your inner dry walls, for example. We detect separately the doors. We can detect the outer wall. For example, if you have this red brick wall here, outer walls, and also outer doors. The new thing that you haven't seen perhaps is that we now also detect the windows. So windows, well, you can imagine if you have multiple buildings, then that becomes relevant.
Again, a question for everybody on the webinar today. How long do you think it would have taken you to manually draw all of these different types of wall segments for this floor plan? Like, I know for me that I think I'm quite a fast wall drawer, but this would have taken me a fair amount of time to be this precise as well. Going around drawing all of the different windows, the different brick walls, and all of the doors. That saved a whole bunch of time.
Yeah, absolutely. Of course, you might need some fine tuning here and there. So make sure you check that all the walls are in place. But another thing you might want to do is that we have a requirement area which covers the whole image. That's maybe not always the case where you want your network to be planned. So you can draw your own requirement area. And we also use automation there. So you can just use our auto area detection, replace the existing area, and it will use outer walls and room detection just to make it more precise to your needs. Right, there is some rogue wall. There's some rogue wall hanging there, but you can easily remove it from your plan, right?
AI Pro Online is checking to make sure you're paying attention, Vlad.
Yes,
yeah.
Absolutely. Okay, but what's new here? One thing that we are adding still to AI Pro Online is the attenuation objects. So those of you who are familiar with AI Pro, of course, know this feature, but now in AI Pro Online, you will be also able to draw attenuation objects, for example, to model the cubicles, the furniture, the crowd, what have you not, right?
So warehouse racks, for example,
warehouse racks,
yeah, like warehouses, manufacturing environments, things like that, where you need to have a bit more freedom in creating bespoke and custom types of areas that can be causing your RF attenuation.
Yes, absolutely. And for example, pillars, beams, whatnot, you can model those, and those, of course, will be accounted also in our automatic planning. So.
Yeah, hey Vlad, where your mouse is on the screen quickly, you can see we've got a row of pillars there, but actually we've not just in the office, we haven't just got a row of pillars, we've got a beam, a concrete beam that comes down from the ceiling at like
exactly. And also in this room, we can. Okay, how would deal with that? Okay, let's see our attenuation object tool, and we have some ready materials. Well, there is no concrete beam, but that's not a problem. We can always create one. So let's create a concrete beam, maybe make it also a color of concrete. And what's the attenuation for concrete beam? I would say 15.
Okay, I would say 16.
Okay, let's put 16 because you know the stuff better than me. So let's set some height for it, maybe 2.3 meters above the ground, and we have our new material. And let's draw this beam going across the whole floor map. And so we have the most accurate model of this environment as possible. So here we have it. So, okay, but just to save this demo time and not draw all the cubicles, whatnot, I have actually prepared a project that is...
I'm not sure that everyone that's joining us on the webinar today came to just watch us draw attenuation objects.
Maybe we can use the time for that, but I thought we might, Let us know in the chat if you want to see me draw all the cubicles in the...
We got half an hour to kill. We can draw all the cubicles in half an hour, I'm sure.
All right. Anyway, I have prepared a project with all the things drawn out, or pretty much all the things we are interested in this demo. So here we have the same floor map. I have actually added some exclusion areas here where I don't want my network coverage. So those elevator shafts and maybe some toilets, maybe in this example, I don't want those. So now I have my environment defined, but well, 2D is, well, you can understand things, but it's this, for example, this beam, I don't really know at what height it is, how it looks. So now I can always switch to 3D mode, right? And you can analyze your design or environment, how it actually looks in 3D, so you can get a better perception of the obstacles there that are accounted for.
Nice.
So you can see that we have the elevator shafts defined, we have these beams, pillars, cubicles, and furniture, and
hey Vlad, just pause there for a second, because that really accurately does reflect like what we have got in the office, like running down there, the pillars, and then the beam that comes down that's supporting for the floor.
Yes.
And like, this is such a nice way to be able to like visualize your environment and make sure that you have built it as accurately as you possibly can. But I really love like what the team has done with the windows there, so that the fact that you can see they're not like from floor to ceiling, and the same with the doors as well, it only goes up to a certain height and you've still got that gap. The way that the development team have worked on these features, I know they've been working really hard, tirelessly to bring them to the audience. I can just see in the chat how much people are getting excited. Can we add an access point, please? Hey, asking you shall receive. Shall we add
Shall
some,
we?
Shall we
I
add
don't
some
know.
APs to the
While you're doing the APs, I mean, think of the additional possibilities here, folks, because even adding signage that comes down, or like big banners and things that are sometimes they're actually aluminum, or aluminium, right? They come down, right? So those things actually make in stores, right? And those are attenuators. So that I would say is that think of the possibilities of adding additional conduit and whatnot that's coming through there, not only just a concrete. Living walls, that's another one that I know we have in the office there, right? So
yeah, for sure. And Brandon, that's what happens when you leave the Ekahau webinar, even for a moment's time, you miss amazing, great new features. So
never do that.
yeah, no, you never know what you're gonna see, right?
Yeah. All right. Hey, somebody asked about APs. Let's add some APs. So I think I'll actually have pre-selected here. I think this is suitable. What do you think, Matt?
Yeah, why not go with a Cisco Wi-Fi 7 access point?
Yeah. And what we see here basically is that you can place, of course, manually your access points. And we have assisted planning enabled. What that means is that we have some proposed locations, but I don't have to use those. For example, if I know that my wires are already going to some places, I can utilize those locations. So for example, I know that there is a place for AP in this conference room and also in this conference room, so I can put my access points there, and Assisted Planner recalculates the proposals based on my manual placements.
Oh, that's interesting, Vlad. Yeah, I noticed that the locations were updating, and correct me if I'm wrong, but I believe that the Assisted Planner, it actually looks at the specific radiation pattern from each access point model that we have in AI Pro Online, and it may actually give different recommendations based if you use Cisco, or someone was asking if we have could we place an extreme AP or for an Aruba access point. So is that right?
Yes, it accounts for all the properties of an access point, including antenna patterns. Of course, we are optimizing not only for coverage, but also for secondary coverage and channel interference, because those aspects will be very important to get a Wi-Fi design done properly.
Okay, awesome.
So let me put maybe some manual access points maybe here and there. But if I don't care about the rest, I can just hit place all button, and it will basically fulfill the design for me for the rest of APs.
And can you now see this in 3D as well, the heat, like, so you can visualize the heat map
I
and
don't
the
know.
access point?
I don't know. Let's try it out, maybe.
Okay.
Let's see what happens.
Ah.
Oh no. Oh yes.
Oh
We
no.
can.
Oh wow. Okay. So there you go. You can actually also see your access points and then the heat maps coming from them. I believe as well, if you select an AP.
Yeah. For example, let's change the height. Maybe we can play around a bit with this. So let's change the height to, what would you say, 3 meters? I don't know. Let's just play around. So you can see immediately. Oh, I've been logged out.
No.
Oh no.
The live demo.
Security comes first always at Ekahau. I forget always that security is the number one. Okay. Anyway, so you can see that you can simulate also in 3D any changes to your environment. You can change the AP heights, obstacle properties, whatnot. And in 3D environment, you can see, for example, select APs and see how that individual AP propagates in that environment. Or
really nice, Vlad. A few people in the chat though asking like when can they expect to see some of these features live in AI Pro? Is it going to be soon? Is it
very soon? I would say very soon. What should I say? Within this month.
Yeah, so you're gonna, don't forget the 3D is already available, but the attenuation objects and things like that, they'll be gonna be coming in the next few weeks. So really looking forward to deploying that, and we wanted to give you a bit of a sneak preview of some things to come, because I personally think it looks awesome.
All right, thank you. Matt, back to you.
Okay, let me take over the screen share, and I will jump back into my slides. So Vlad, you showed us some cool things that are already going to be coming in the product, but maybe you can talk through a few other features that are going to be coming in the near future as well, like such as maybe that capacity planning.
Yeah, so as I mentioned, we are collecting constantly feedback from our users, from customers, their requests, and the capacity planning has been one of the most requested feature. Of course, for those of you who have been using AI Pro Classic, that feature is no-brainer. It exists already there. But in AI Pro Online, we're adding capacity planning, which relies on a relatively new concept. So what you will be able to do, you can, for each of your requirement areas, define capacity requirements for each of the bands, and we will automatically calculate and propose default profiles. For example, you draw an area, and then we show you that with this default profile, you will have, for example, 100 clients supported within that area. So for each area, we will calculate and display you how many clients that area will support. But you can always create a custom profile or change it to another profile. And for example, define how many clients maximum can be connected to a single radio. So that is all coming. And of course, we will have a capacity heat map, which will tell you immediately, is your capacity in order, or do you need to add, for example, more APs or radios?
Got it. Great. Cool. And then I think there's some other new things as well that you wanted to just touch on quickly too, Vlad. Is that right?
Yeah, absolutely. So for example, regarding visualization settings and 3D especially. So in 2D, yes, it's okay. But when you look at the heat maps in 3D, sometimes it's good to know, for example, in warehouse environment or somewhere you need, for example, coverage on a certain height, for example, on the 5-meter height where some drones are flying or some AGVs or whatever is happening there.
Well,
so you need coverage.
That actually happened to us when we was doing a warehouse. There was some of the racks down the aisles. They went from ground up to, I think it's like 15 meters high. But the actual requirements that was defined with the stakeholder is that the Wi-Fi had to work at not all the way back and forth down the aisle, but also at any height down the aisle, because they had these trucks where the cab of the forklift truck would actually go up with the, I don't know, whatever you call them,
forks.
Yeah, okay. Gosh, I made myself look so stupid then. So the cab would go up with the forks of the forklift truck, and the guy or girl driving the truck would actually have a scanner, and they would be scanning the barcodes at each different height of the racks and the pallets and stuff like that. So being able to actually see to make sure you've got coverage of those different heights is going to be really crucial to when you're planning, and especially if you have a requirement like that. That's just one example. I'm sure we've probably got some more we could see in the chat as well.
So for that case, what we will do, you can tell AI Pro Online at which height you want the heat map to be calculated. And you can also tell, do you want to see the heat map projected to the surface of your plan, or do you want it to be displayed on the height you have defined? So that is all coming to AI Pro Online as well.
Okay, and what's this, Vlad?
This is the most exciting thing for me, at least, from the upcoming features. So I'm not even joking. I think this is the future. So basically connecting to your network controller and getting real-time data for your plans. So what you will be able to do, for example, you don't have a survey, right? And maybe you don't want to do a manual design. So what you can do, you connect with API key to a site, to the network controller. You pull out data, for example, floor map and AP configurations, and we will automatically generate walls, obstacles, and via that you will see also heat maps. And what's beautiful about that, we will be updating the data from the API to AI Pro Online, so you can see in real time how many clients are associated to different radios, for example. You will see how the TX power changes, potentially channels are impacting your network, or anything that comes from the API will be visible in AI Pro Online. So I'm really excited when we will have this.
Yeah, this is super exciting. I'd maybe just add that it's still crucial to go on site and be able to do those surveys, but you've now got just multiple different options to be able to get data that you can pull from, that you can analyze and then improve the performance of the network. And it's going to be a great way for you to be able to visualize things. And I've got a lot of people asking about vendors, so of course we will obviously support all of the major AP vendors, but you're going to have to wait and see when we get a little bit further down the line with this feature and we do a nice live demo for you a bit as well. Okay, all right, this is the part where I really wanted to spend a little bit of time covering some questions. I know when I was really kind of like getting my teeth into Wi-Fi and doing some of the designs for the first time myself, I was reading things, I was listening to podcasts, I was attending classes, and I would always hear these kind of questions. So one of the ones that would come up so often would be like, why should I not, like, you don't place APs in corridors, like don't place APs in corridors, that's the worst thing you can do. And I was like, why is it so bad? Because I remember I would walking through hotels and other environments, and you would just see AP in a hallway. So why don't we jump into a example here in Ekahau AI Pro Online. So what I've got is a floor plan. I've got all of the walls drawn. I've just turned them off, but I'll just turn them back on so you can see them there. Because I really just want to focus on these two access points for now. And basically I placed one access point here in the hallway and another access point here in the hallway as well. And then the other thing that I just want to draw your attention to, as I move my cursor along the heat map, can you see down the bottom, like it updates what the signal strength is? So we've got an access point placed here, and we can see how far it covers with the coverage going down to here. And if I turn on this access point down here as well, you can see it does overlap slightly with this access point down in this corridor as well. I mean, obviously you wouldn't do a design like this, but for a demo purpose, I just want to show you what might happen if you have access points placed in the corridors. So let's say, for example, we've got a client device in room C19 down here. And let's say that this client device is associated to this access point. As the client device walks out of the room, goes down the corridor, obviously it's associated to this access point. So if I just turn on this AP for now, as I walk down here, the current connectivity for the client device is pretty good. So all the way down the corridor to this point, it's at a signal threshold, which would be, it would still be deemed as like a good coverage for the client device. So the client device wouldn't be thinking at any moment in time right now, oh, I need to go and discover another access point to go and roam to. I need to start scanning some channels. I need to go and look for another AP because my signal's getting weaker. So what would happen now is, if let's say that you make a left turn and go down this corridor, you go from having fairly strong signal at minus 66 dBm, and you take a few steps, and all of a sudden the signal has completely dropped by like a significant amount. Also, that past that threshold where the client device would probably be thinking, oh, I definitely need to roam to another access point now. Almost as well, like the coverage could have almost just disappeared from the perspective of the client device. So now the client device was just a second ago, like even less than a second ago, it was enjoying life. Life was all good. I've got great signal, I've got great coverage. I don't need to go find another AP to go and roam to. So all of a sudden panicking, going, Vlad, I need to go and find another AP to go and connect to. So it's going to be quite a bad experience for the client device. So how can we make that slightly better? So from this perspective here, if we've got the access point in the corridor and we've got this AP in the corridor here, obviously we'd probably have some more access points. And if we did take the approach of the hallway design, so I'm just going to copy and paste a few access points down here. Maybe I should put one here, and let me just add one more, like over here for argument's sake. And there are some things and protocols in place that can actually help client devices with roaming. One of them being something that's called 802.11k neighbor reports. So an access point can form a table or a list of its nearby best neighbors. So when a client device is going to be roaming to another access point, the AP can inform the client device, hey, Mr. Client Device, instead of having to go and scan all, I don't know, 80 Wi-Fi channels, you can just go and scan my next best neighbors, and that will speed up the roaming process for you. But let's say in this example as well, let me just put one more AP down this part of the corridor. So again, like this access point here, it can clearly hear this AP, this one, and it will be able to hear this access point. So if I just turn on the heat map again, and let's say again, we're in C19 and we walk out of here and we walk down the corridor and then we go to turn a corner. I'll just turn on this AP again. As we turn around this corner, and let's say if we wanted to leverage neighbor reports, bear in mind that the access points they don't physically know where the other APs are. So all this access point can do, let's say it's formed its neighbor list, it would be building a neighbor list of these access points over here. There's probably no way, even though there is a slight overlap because of the threshold of the overlap being so much lower than compared to the other ones, that this AP would be in the neighbor list of this access point. So again, like it will really potentially make roaming bad for your client devices, putting them in the hallways. There's a couple of other things as well, like why you wouldn't want to place access points in the corridors necessarily, because you really want to place access points where the main location is going to be for where your clients are going to be actually using the network. So in this scenario, you'd want to put them in the rooms because that's going to be the place where you're sitting down at your desk, you're doing your work, you're joining calls, etc., like that. Realistically, yes, you may be on your phone, checking an email, whatever, walking through the corridors, but the main purpose is to be connected in the rooms. The other thing, if you have all of the access points in the corridors, if they can hear each other really well and you haven't set, let's say, a threshold limit for your radio profiles and the transmit power, sometimes if access points can hear each other too well, they'll reduce their transmitting power down to a very low amount. And if you've got a low signal, that means you're going to have low MTS, use a lower MTS, which means slower data rates, which means a poor performing Wi-Fi network. So what I would do in this scenario instead is I would move these access points inside of the room, and let me just move it to here, and inside of here, and inside of here. And let me show you why. So if I turn on this access point now instead, and then let's say again, we're in C19, I come out of the room, I walk down the corridor, but as I walk down the corridor now, you'll see that there's like a nice degradation of the signal. So I go from having the good signal and it starts to go down, but there's never any kind of moment where it's like a crazy jump off of a cliff. And this means it gives the client device time to go and find another access point to go and roam and associate to. So all in all, that would be why I wouldn't want to place APs in corridors for my designs. And let's jump back to some slides because, Vlad, I think there's another new thing coming soon.
Yeah, so related to what you just showed, that roaming is very important, and we are planning to introduce a very exciting tool to AI Pro Online called Inspect Tool. What you will be able to do, you point to any place on the map, it will create a pointer, and it will actually show you in-depth analysis of that location. For example, it will show you the overall network health for all the heat maps. It will show which radios are heard from that location. And most importantly, it will show you also to which AP, to which radio it is likely to roam when you move the pin around. And we hear a misconception often that the roaming will happen to the second strongest radio, right?
Yeah.
And it's not always the case. So we have an algorithm actually which estimates much better to which radio the roaming will happen.
That'd be so helpful for understanding like your environment and how different clients, what will happen when different clients traverse through your network. So I'm really looking forward to seeing that as well. Okay, I'm going to try and answer two questions at the same time now that I used to have in my head quite a lot as well. Why I shouldn't place access points with integrated omnidirectional antennas above a certain height. I was always told like the golden rule is like no more than 5 meters or 16 foot. When you start to go above that, it's going to make the performance of the client devices not so great. And I was always like, well, why is that? And then another one is why you shouldn't install omnidirectional access points on a wall like a clock. So again, let me just jump back into AI Pro Online. I'm going to do a couple of quick demos. So I want to just jump to a blank floor plan actually. So I've just got a blank floor plan here, and I have, I've scaled it and I've just placed an access point so we can see the heat map visualization from the access point. So like this is the coverage coming from the access point, and this is currently at 2.4 meters high. And I don't know about you, but I've actually seen some access points installed like super high, 10, 15, sometimes even higher in different environments. So you can see here like the different coverage coming from around this access point. And if I was to change this now from being at 2.4 meters to, I don't know, let's say something pretty high, like 15 meters, watch what happens to the heat map. So when it goes like super high, you can see there's such a change in the coverage from the client's perspective, because there's such a height difference now in the degradation coming from the radio, from the access point. By the time it gets down to the ground now, the signal strength is going to be lower. The MCS means is going to be less complex, and you're going to have a lower data rate, so slower performing Wi-Fi network. So this would be a reason why you don't want to install access points with integrated omnis that high. If you do need to do that, I would use directional antennas and focus the energy down. So I'm just going to put this back to 2.4 meters, and I'm going to change the ceiling mounted option to the wall. So now you can kind of see like it's not a perfect circle, but you can see like the radiation pattern coming from around the access point. So horizontally installed underneath the ceiling. And watch what happens to the radiation pattern now if you change this Omni AP to being on the wall. So now rather than spreading the coverage out horizontally, when you put it on the wall like a clock, you actually have better coverage going up and down than you do covering the floor that you're on. So this for me was a great way when I was learning in the ECSE classes to visualize the impact of installing these types of access points incorrectly. So hopefully that helped you as well. I can't actually see the chat and comments at the moment, so I'm trusting Stu and Dale's keeping a close eye on that. Another big question that we get a lot is, should you apply offsets to your designs? Which is a great question. And I mean, like, what even is an offset? So an offset is when you basically apply a subtraction to the heat maps that you can visualize in Ekahau. For me, it just has a simplistic answer. If you do a validation survey and you have measured data from the Psychic 2, then yes, you can do a offset. So compare your client devices, your real world devices that you have in your environment, how they hear the Wi-Fi compared to the Psychic, because the Psychic has got its own antennas and radios, your phone has got its own antennas and radios. They're going to hear the Wi-Fi slightly differently. You can record that and then apply that offset. When I'm doing a traditional predictive design, like we spoke about on the right-hand side, I don't typically apply an offset to my design, especially not without going on site and measuring with a Psychic 2, because what we're doing on the right-hand side is we're just basically applying science and math, so physics, to what's actually happening from the transmit power of the radio down through what's going on with the subtraction of attenuation, free space path loss, reflections, and diffractions. Yes, I would go on site, measure, verify my validation survey, and then match what that is to my predictive model to ensure it is as accurate as possible. And Vlad, I think there's going to be something coming soon as well into AI Pro Online to be able to visualize this,
yes,
right?
Absolutely. So we will be introducing offset profiles and device profiles, so you can also create custom offset profile and play around with those.
So again, one of the reasons why you might want to do that is because you may have heard of a term called the least capable, most important device. You may have to support in the medical industry, some medical devices that can't really be updated. Maybe they've got really old, crappy radios and they don't hear the Wi-Fi quite so well, but you want to ensure that the new design that you do, they're going to still be able to meet the necessary requirements. So what you can do is you can grab that medical device, and what I would do is set up an access point, or if you've already got an AP set up and configured, take the Sidekick, take the device, go to some locations. I would ensure you is at least 4 or 5 meters away from the AP, record some measurements, go to a few different locations, and then each time you can see here, there's roughly around a 5 dB difference. Then you can go into Ekahau, and just like Vlad said, you're going to be able to create a custom device profile and then put in those custom offsets for your devices in your environment so you can visualize the heat maps and make sure that your network and your design or your validation, the RF from the perspective of your necessary client devices that you need. Quickly to summarize the webinar as we're drawing to the end of the hour. Don't worry, we will stay on for a little bit longer and answer questions. I can see there's a lot in the chat and the Q&A that we haven't been able to get to yet. So to summarize, some best practices for your Wi-Fi design, making sure you speak to the stakeholders and gathering those requirements, because that is a key thing to make sure that you document what the business requirements are and have something in place to say, I'm going to deploy this network and it's going to meet these requirements, and I would have it documented in a report. So when you actually go and do the design and then you go and validate it, you can ensure that what you've deployed actually matches what you said. And that's going to be a great way of reporting and documentation. I can't stress enough the importance of being on site. There's so many benefits of it, being able to see mounting locations, discover any interferers, measuring attenuation of all your different objects, and just having a good time. Who doesn't love going on site and seeing new environments? Also, whilst you're there, you get a great visibility into the RF environment. So how noisy are your neighbors? We're on the 7th floor here in a multi-tenanted building. We have some pretty noisy neighbors with their RF on the floors above and below. So maybe we want to avoid some of those channels. Maybe they're using some really wide channels. Maybe there's some interferers here. We do have quite a few quirky devices in the Ekahau Helsinki office, I'm sure you can imagine. So there could be some non-Wi-Fi interference that you want to avoid. And then I love point 4 where we say here, cover what you want whilst not covering what you don't want. So ensuring that you provide RF to the places that have been defined for in scope and not worrying too much about those areas that are out of scope. Then point 5, making sure your configuration matches your design and what you planned for the network to be. So the configuration of the radios, especially around transmitting power, channel widths, the channels that you're using, even the amendments that you want to turn on. SSID configuration is going to be your best friend for deploying the Wi-Fi network and making sure your design makes it right the first time. Then, if you've enjoyed the first webinar of 2025, we actually have some amazing training courses. And what I really love to see at the start of the webinar today, people are saying that they're taking the ECSE classes soon, or they're thinking about taking ECSE. So we actually have 3 different instructor-led 4-day classes that can be delivered virtually or in person. So if you're enjoying a Wi-Fi design webinar, maybe you'd enjoy our ECSE design class, where we dive in. We're really just scratching the surface on the webinar. We've got a 1-hour bit of content today, but we spend 4 full days covering everything you need to know around Wi-Fi and how to design an awesome Wi-Fi network. Or perhaps you work in a support team and maybe your main focus is actually just around troubleshooting and supporting Wi-Fi networks, then our troubleshooting class could be perfect for you. And then our advanced class, maybe you want to learn some of the more fun advanced features and things that you can do with Ekahau and Wi-Fi, things like, our custom template reporting, or maybe some things around our floor plan manipulation. Or if you want to just, watch some self-paced video on demand training, we have a few different options for you there down below. So we want to tell you about our next upcoming Wi-Fi webinar. It's all going to be around the fundamentals. We're going to have a great guest join us as well in Francois, one of our amazing ECSE instructors, and we're going to be breaking down the fundamentals of RF and Wi-Fi and everything that you need to know to ensure you've got a great Wi-Fi network. Thank you so much, Vlad, for joining us today. This has been an awesome webinar. I loved it. Love seeing all of the demos and the new cool things coming with Ekahau AI Pro online. I don't know about you, but I loved our first Ekahau webinar of 2025. Thank you all so much for joining us. It's been great to have you here. Hopefully you signed up, or you're going to sign up for the next one on January 30th. It's going to be an amazing webinar as well. And a big thank you to Stu, Dale, and Vlad for putting up with me in person. I know I've been pestering you all week in the office, trying to get you to do some marketing stunts. And he secretly can't wait for me to leave to go back to the UK tomorrow, I think.
We can do next webinar next year, maybe. Okay. One more time.
Wow, that's our limit. One webinar in person together. First one in 4 years, and then we can do one per year. All right. Well, Thank you so much, everybody. Have a great rest of your day, and we look forward to seeing you on the next webinar.